Hey guys, welcome to today's video. So today we're going to cover the CNC machine some more. I know it's been a while since I did a video on this. I was kind of waiting to clean up the garage here, but I decided that's never going to happen. So let's take a look at it and just see where we're at. So as you can see, I'm currently just working with this little deck right here. I haven't got enough waste cord yet for the whole thing. I initially had built it with the original design, and it really didn't go down far enough, but he made a modification for it after I'd started building. So now it goes down plenty far for any use that I'm going to be doing with the CNC machine. So I have the updated X-axis, which is really the Z-axis here, but it's part of the X carriage here. So yeah, got that update done to it. One of the other things I wanted to show that I did differently is I ran all my cables this direction, so I had to redesign this guy because it's meant to be on the opposite side of the CNC machine. So that's another modification I did. I flipped these and put them on the exterior instead of the interior, mostly just because my trapezoidal rod for it, or acne rod, was sticking out that far, so I was just like, shoot, I'll just flip this over. That should help with some of the vibration. I'm not sure if it really helps. I still haven't finished printing all of the clasps for the for this. I honestly wouldn't even recommend 3D printing this. I don't like the 3D printed drag chain. I'd prefer to just buy one instead. I haven't looked into prices though. These might be expensive, so I'm not sure how much that costs to buy one, but I'd almost recommend just buying it because it takes a really long time to print all of these, and they're kind of a little bit floppy here. I don't know. It's not as erect as I'd like. They're kind of flaccid. It all works. I wired it up a little bit differently, as I talked about. I use stepper drivers instead of the board that goes on the Arduino. But yeah, there's wires down here. Total rat's nest mess here. Maybe one day I'll clean it up, but you know how that goes. Those maybe one days never happen. So yeah, I'm running Universal G-code sender on it. Let's pull this up here. Okay, so there's Universal G-code sender on here. I had printed something last night, so this was still open from printing it. But yeah, that's kind of the general overview of it. I'll try to record you a little shot of it running, but it definitely works. I got it with a 1/4 inch bit sitting on here. I have an 1/8 inch. Something else to mention, these are terrible. I've broke like 2 or 3 of them already. So I ordered these guys as a replacement. So I'm about to put those on there. These give it a lot of play. They move back and forth, which then causes the whole thing to move back and forth. So yep, this junk's going now. Alright, so before we get too much further into this video, let's go ahead and replace these guys on here. Okay, I was doing some editing and I noticed that the AC unit was really loud, so I turned it off in these next couple of clips. But yeah, so I got the new couplings put on there for the trapezoidal rod or acne rod. I guess it's only called acne rod if it's SCA, and these are definitely metric, so I think they're just called trapezoidal. But I'm not an expert in that stuff, but let's go ahead and do some jogging with the machine real quick. So I'm going to power it up. So I got the Arduino hooked up to the computer, and I got that. And I just got a strip of light down here, so that way I know when I have power to these motors, so I don't hurt myself. So let's go ahead and open this connection. And this is, again, Universal G-code sender. I'm using version 2.0. It's still technically in beta mode, so there's just some glitches here and there. Let's go ahead and just do some jogging. So nothing super impressive here. speed this up a little more. Okay, so kind of boring, but we just jogged the machine. So now we can see that it works. So now we just need to make some G code to tell it to cut something. And by the way, here's the spindle. It's kind of loud, so if you're wearing headphones, this will probably come across really loud. So yeah, as you can see, it's quite a noisy machine, so probably shouldn't be running it after 11 p.m., which I have a couple of times, so sorry to my neighbors. But yeah, this is what's been occupying my time for so long now, and why I haven't been making a lot of videos is I've been learning how to do this. I've cut out some shapes for my wife, like a little heart for her to do a little sign for her garden. Same with a little elephant for my kids, and I cut out little door signs for the kids' doors and all of that. So I've been learning how to do all this. I've been doing it all in Fusion 360 because I want to learn CAD and CAM, and I've been using that as my CAM software. So yeah, it's a pretty cool learning experience building your own CNC machine. To me, it's definitely worth it if you are looking to learn exactly how the machine works and understand exactly why everything does what it does. If you're just looking for a CNC machine to start making money and start making wood chips or metal chips or whatever you're trying to do and just get started, I wouldn't recommend just building your own machine. I would say if you're just trying to get started for a hobby, check out the Chinese machines you can get pretty cheap on like AliExpress and all those. If you are looking at trying to do it as a business, I mean, I think it's kind of hard to beat like a Shapeoko because there's a huge community around them. They're very well supported machines. So, and if you're looking to cut some metals and stuff, you're going to look into some different machines than that. But the Shapeokos apparently are good for cutting aluminum. I've never used one, never touched one. This is my first CNC machine. I wanted to learn how they work. I wanted to learn about the electronics of it, and I wanted to learn a little bit more about Arduinos. So that's what this is about. For me, it was a learning experience, and that's why I made it. It's kind of an expensive learning experience. This wasn't a cheap build at all, but I figured I'll probably be able to make my money back out of it. I mean, this in all cost me about $750 to build. That's counting the table, which was about $100 worth of lumber and fasteners to build this, and then it was probably another $650, maybe another $700, but no more than $800 total here. That does not count the laptop. I already had the laptop. The Arduino is not counted in that. I already owned that too. But everything else was a new purchase, so it was easy to count. Arduino is cheap enough. I don't think you really need to account for that. But that counted all the PLA that I used to print it. And I estimated in some of the electricity for printing them. I didn't go for super accurate numbers because I really wasn't too concerned. But yeah, it does not count any labor though. There's no labor at all. If you count labor, this thing was like $3,000 or $4,000 to build. This was way more expensive if you count your labor. I probably spent a good full 4 days building this, but I spread it out, so it really took me like a whole week to build the machine. But if I were to sit down and do it, it probably would have taken 3 days straight of working on it. But yeah, hopefully you like the machine. Let's cut over to the computer and do a little bit of CAD and CAM work, and then cut it out on the machine so we can see how it works. Okay guys, I promise you I own the rights to this picture. Alright, so yeah, you just use your fuzzy select tool here in GIMP. If you're not familiar with GIMP, it's a pretty decent free image editing software. great for when you're trying to get into like web design or something like that. But pretty cool thing you can do here is turn things into SVGs, which SVGs are great because they're scalable vector images, really good for working in CAD and stuff. So we're going to take this cactus design here. We just want the outline of it. We don't care about the image here. We're going to cut out a cactus. So let's take this and we go to selection after we use our fuzzy select. So fuzzy select's right there. Just set your threshold when you're dealing with these, which have like a watermark on them because they didn't want you to pirate their image. You just set your threshold real high and you can get past it. Alright, and so to path, and now we've created a path of it, and we're just gonna go export that path, cact.svg. Alright, and I'd say this is probably fair use because we're not really using the image, we're just taking a look at it. Alright, so discard, we're no longer using that image. Let's go into Fusion 360. Alright, so we're in Fusion 360. Let's insert SVG, pick our plane, open up, see SVG cat, because it's definitely a cat. And let's move it to where we want it. Alright. Get it right about there. Alright, yeah, 100 millimeters. Let's go a little bit bigger. So here is the scale. We'll scale it up. The bigger you get it, the touchier that goes. So there we go. We should be at like 150, 150 mils. All right, let's move that down just a hair though. Alright, so now we finished sketch, now we have our SVG here, and we're going to extrude it up to the height of our material, and I'm just using 1/2 inch, so 13 millimeter MFD is what we're using. So there we go, 13 millimeters, and now we have a cactus that we can cut out with the CNC machine. So now let's go into CAM, do this. So manufacture. Now we're in the CAM software and we can do this. So some of the stuff go into, so we do a setup. We're going to set it up to our stock size, which I actually haven't cut out a piece of stock yet. So it doesn't really matter. We'll just do relative to size or do a fixed size and just drop the height down to the correct height. I'm not going to worry about the rest of it just because we are going to just make sure we get it in the right corner of the piece of wood and not worry about the rest. Normally I set it to the actual stock size, but since I haven't cut something out yet, we'll just work with it from here. Let's get back into that setup though. Let's finish. Alright, so operation milling machine, I just have mine saved in here. Alright, our center point, I like to work from that bottom corner there. It's just easy to remember. It's not bad to go there either. Those are my two go-to spots. We gotta get that set to fixed, and we'll just name this cat, even though it's a cactus, not a cat. Alright. So then we're going to do an operation. We're going to have a mill. I'm using my 1/4 inch bit that I have saved on there. That's what's on the machine right now. We're doing, I don't have any coolant, so just disable coolant. And contour, we are going to contour that. We are going to put some tabs on it so they don't go, it doesn't go flying off. Let's see, did it do more than one? No. Let's change that until we get a couple of them on there. Let's go with like 40. That got us three tabs, should be good enough. Alright, we are going to also set the tool orientation. It's going to be there. So that's good. And then passes, we are going to have multiple depths. We can get away with like 2. 2 is fair enough. And yeah, we're not trying to go for the prettiest thing here, but this should work. Alright, so there we go. It's gonna take a couple of rotations there. So now we can post this. Yeah, it looks like we did have plenty of room. I was concerned with the room in between here with the 1/4 inch bit, but it looks like we're good. So now that we've done our setup, we've done our cut that we're going to do, because we're not going to face the top of this. We're not looking for something perfect. Let's go ahead and generate our G code. So let's change this to save to a folder that's easy for me to find. I'll just do my downloads folder. Alright, and we need to set, I don't need it to write machine, I don't need it to write the tool list, I don't need it to output the tool number because Gerbil doesn't support that. Alright, and there we go. So yeah, that's good to go. So we're going to go ahead and post this. We've now posted it. We have one error because I didn't set the job that it's doing. But let's go ahead and open this up in my downloads because we got to edit out a little portion of it. I don't know why it gives me problems. I don't know exactly what the code means, but let's get in there. And for some reason, this one, which I'm not sure what it is, causes problems. I just delete it out, and that's good to go from there. So Control save, and now I'll just move this over to my thumb drive and take it over to the other computer. So let's go check this out. Okay, so I got the camera a little closer here, so hopefully the audio comes in better. I'm having a hard time figuring out this whole audio thing. But let's go ahead and get this guy set up. Yeah, it's just had that sitting on there as a little weight. I just currently use blue painter's tape and super glue to attach things. So you put a layer of tape down on your wasteboard, then you put a layer of tape down on your stock material, and then just put some super glue in between the two. Comes off here relatively easy, and you don't get everything all stuck together. So let's zero the machine and put the thumb drive on here. So thumb drive on. If I can find the hole. All right. Give the machine power. All right. Hopefully that doesn't. The Z-axis doesn't catch it. So there we go. The Z-axis high enough, so now I can start zeroing the machine. So as we did in the software there, we set this corner here to be our home, or our 0 point. Alright, went a little past it. Let's go ahead and step down. Let's go to 10. Alright, bring it down to 5. Alright, so we're going to then in the software here, let me rotate it so you can see. So reset our 0, reset all our axes too. Alright, then we're going to open up our G code we just made. So, let's see. Okay, so now it's about to get loud. I'm going to go ahead and turn on the spindle, and then we'll tell this thing to run. Okay, so we're done here. You can see I didn't have it perfectly level. We got a little bit leftover paper there, but that also may be just the down cut didn't push hard enough. Let me find the cutters here. Go ahead and just cut these little tabs off so that way we can take it off. And there's one more. Alright, so there we go. There's a little cactus we cut out. You can see it caught a little bit of that heart shape because I was just using a piece of scrap wood to cut this out here. But yeah, we got these little tabs here, and you just cut them off with some flat cutters. Works good with this MFD. and then you just take some sandpaper and clean it up. But yeah, machine's not perfectly level yet. Still gonna take a little bit of work to get it perfect here. But yeah, you got a little bit of tab sticking right there. So you just take some sandpaper and just knock that off after you clip it. And super easy to do with the MFD. It's not much effort at all there to clean these up. But yeah, simple little cactus design there. And just shows you that the CNC machine works. That I didn't just waste, shoot, a week, 2 weeks of my life making it. So, like I said in the beginning of the video, it was like probably 3 days worth of labor putting the thing together. But that doesn't count running the 3D printer. So it's probably add another 3 days of labor to it. It's like 6 days total once you count running the 3D printers the whole time too. So this is definitely, if you want to build it, you better have some time on your hands to build it. Better be ready for the cost of it too, because it's not free to build. So yeah, if you're looking to just get started making money with a CNC machine, not the machine for you. If you're looking to really learn how CNC works and build something yourself that you can take pride in, this is the perfect machine for you. It's not too hard, it's not too complex to build, and you don't need too many specialty tools. You only need a 3D printer to print the plastic, some screwdrivers, hex drivers, and you'll need a saw capable of cutting metal. I used a cut-off wheel to cut these metal rods here, and to length. You might be able to order them to length somewhere, but yeah, and you need to drill and tap on right here. So not too many tools involved in building the whole thing. Definitely something that anybody with some basic mechanical skills, like working on cars, something like that, can definitely achieve. So hopefully you guys like the video. You can give it a thumbs up and leave a comment down below. And maybe I'll get back to my normal routine of making videos, but I doubt it because I'm starting to work on moving back home to Florida. So yeah, I'll see you guys in the next video.